Okay, we're going to start with this bell work with actually an ACT problem. Now, both of these trig problems I picked out because they take into what you have learned already about trig and help you practice that, but in a more applicable way. So in this case here, you're given a triangle, KLM, and they want to know what side is. So if you remember SOHCAHTOA, so for side, it's opposite over hypotenuse. So in this case, they want to know the side for M. M is right here. So here's M. If you want to know the side of M, that means that this is going to be your opposite over hypotenuse, which in this case here is going to be whatever this value is, that's opposite, and this is the adjacent, this is the hypotenuse. So it's like we know that it's something over 12. So we need to figure out what this side is. And to figure this side out, let's call this x here, we have to use the Pythagorean theorem. So the Pythagorean theorem that we've been using is r squared equals x squared plus y squared. So let's just use it here. So I know my hypotenuse is 12. So that's going to represent our r here. R is just a hypotenuse. And so that's going to be 12 squared equals x squared, which I don't know x. Y, I'll just pretend this is my y here. So I already know one of the sides, which is 10. So if I work this out here, I have x squared plus 10 squared, which is 100. This side, 12 squared is 144. If I subtract the 100 to get the x squared by itself, this cancels. So I have x squared is equal to 44 on this side, so I have to take the square root of both sides to get the x by itself. So x is equal to the square root of 44. So if that's by x value, I'm going to place it here. So I'm going to look for the answer that looks like this, which is k. Done. Okay, so that one there, you just needed to know what SOHCAHTOA is. Side is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then this one here, we're going to take a look at. So this one says, which of the following trigonometric equations is valid for the measurement x inches, diagonal measurements y inches, and angle measurements w in the rectangle shown below? So in this case here, if this is w, right, it wants to know which of these trig function is true. Well, if you look at the triangle here, right, you only have the opposite over hypotenuse. What takes in opposite and hypotenuse? Isn't that just side, right? So in this case, side, if we have a side here for w, that would just be your x over y. So in this case, do we have a side? Yeah, we do. So in this case, it would be D. Now, if you didn't see side, you might also be using the reciprocal, which is the reciprocal of side, and that's y over x. And you can see if there is something that's cosecant y over x. But in this case, I didn't see any cosecant, so I couldn't use this option. So this is the only valid option here. So the answer is D. Okay, so in these problems here, I'm picking problems from chapter 14.1, 61 to 80. And I'm doing problems that you're going to see where I'm solving all 6 trig functions or solving for a trig function. So this problem here is taking into account, it gives you a side, like a trig function with its ratio, and it tells you the quadrant. So it gives you these two pieces. And from these two pieces, can you identify what this trig ratio would be? So it wants to know what cosine of that angle would be. So to do this, you need to first understand what you already have. So in this case, you need to determine if you have all your x, your y, and your r, because you need all of those 3 ingredients to figure out what cosine is. Because cosine is going to be, so let me put this to the side here. Cosine that we're going to be finding is going to be by x over r, right? So in this case, I need my x value. So let's see what I'm given. So here's sine, right? The thing about sine is that sine, grab a blue pad here, sine is y over the radius. So in this case, I only know that my y value is 3 and my radius is 5. So I need to find what my x is, but I don't have it. So I have to use the Pythagorean theorem. So if I use the Pythagorean theorem here, x squared plus y squared, if I work it out, I just plug it by 3, and I plug it by x. Actually, let me make this correspond. So this would be x squared plus 3 squared and 5 squared. So this would be 25 on this side, x squared. This would be 9. I would subtract off the 9, move it to this side. So that I would have 25 minus 9, which is 16, equals x squared. So x is equal to 4 if you take the square root of both sides. So if x is 4, I could put it back into here as 4. So I've solved for all 3 sides. So now that I know that, well, I have x and I have r, so I could put these back together, right? Actually, no, you need to pause here. So take into account that it needs to satisfy the second quadrant. So the second quadrant, I want you to think about what is the signs in the second quadrant. So in the second quadrant, the x values are negative and the y values are positive. So in our case, our y value is positive, but actually turns out this 4 is a negative 4 because it needs to satisfy the second quadrant. So this x turns out it's a negative 4. And you wouldn't be able to see that unless you looked at the quadrant and those sign values for that given point. So this is actually negative 4, your x, over r, which is 5. And so this is here your actual answer for cosine. All right, let's do another one of these. So this one here, we're going to do the same things. We got to take these two trig functions into account and the quadrant. So first, we're going to name down what is our x and our y and our r. Now, we're given cotangent. Okay, so just to, remember our trig functions here, cotangent, if you look back at your notes, cotangent is going to be, I'll write here on the side, your x over your y, okay? So in that case, you know that this negative 1 here is your x, and your y here is your 3. So you don't know what r is. So we're going to have to find r using the Pythagorean theorem. So if we plug everything in, our x and our y, that's going to be negative 1 squared plus 3 squared. So if I work it out, I have 1 plus 9. So r is going to be, r squared is going to be equal to 10. And so r is the square root of 10. 10 can only be broken up to 5 and 2, which are not pairs. So in this case, I can't simplify this radical anymore. So this is all that I have. So I have found my r, which is the square root of 10. So now what I'm going to do is I need to check my quadrant. So this quadrant here is in the fourth quadrant. So the fourth quadrant's down here. The fourth quadrant is both negatives, right? So in this case, not only is our x a negative, our y is a negative too. So I need to pop in a negative side here. So that's really a negative 3. And so now I have to take a look here what I'm trying to solve. I'm trying to find cosecant. So cosecant is, well, it's the reciprocal of sine. So that's going to be r over y, which is going to be r, the square root of 10 over y, which is -3. And that there would be my ratio for cosecant. Okay, so our next one here, we need to find the secant, our secant, and secant is the reciprocal of cosine, so that's going to be r over x. Given that we know the tangent, so square root, and then the third quadrant. So first let's start off by knowing what is our x, our y, and our r. So tangent is, let me write this to the side here. So tangent is your y over x. So in this case, y is the square root of 7. So I'm going to grab that square root of 7. And then our x must have been the 3. So I don't know my r, so I have to go ahead and solve that. So I'm going to do that here. Oops, sorry. That should be a 7. So 3 squared gives me 9. The square root of 3, the square root of 7 is, when you square it, the square and the root cancel, so that just brings out a 7. So 9 plus 7 gives me 16. If I take the square root, r is equal to 4. So this here is a 4. So now I have to check my quadrant because we're in the third quadrant. Oh, I think I messed up on the last problem. Yes, I did. This here, the third quadrant, is the one with the negative. My bad. But I'm going to finish this problem up and then I'm going to come back to 63 because I messed up. Okay, I'm going to go back here in a sec. So looking at this quadrant here, I have, so third quadrant, negative. So that means that my x and y are both negative signs. They both have a negative sign. So in this case, when I find my secant, which is my radius, which is 4, over my x, which is -3, that is going to be my ratio. Okay, let's go back to 63 and make sure that I need to see if I need to fix my signs here. So I was wrong. It's not. This is not the fourth quadrant. The fourth quadrant's over here, right? And so that would be positive for x and negative for my y. So given that piece of information, that means that my x value here needed to be a positive sign. And my y here is a negative, right? Oh, but I guess the radius here and the y was all that we wanted to know. So I actually got the sign right for y, even though I was in the wrong quadrant. So yes, it's still actually -3 and a square root of 10 on the top. So this is still the correct answer. But if it had asked for the secant, I would have messed up because that sign would have been a positive x. So anyhow, these still are the same answers. Okay, one more slide. Okay, so in this case here, it's kind of like the same problem that we've been doing, but it's now wanting you to find all 6 of the trig functions. So you actually have one of them already, you have sine, but you have to find the other 5. So in this case, let's go ahead before we find all 6 trig functions that we try to get the first x, y, and r. So we want to first always try to find x, y, and r because that's what our trig functions are made of. So in this case, we have sine, right? So if we have sine, that means that sine is my y over r. And so in this case, my y here is the square root of 2, and my r here is 6. So in this case, if I want to get my x, I need to use Pythagoreans. So we're used to using that now. So we're going to plug stuff in. So x here, I don't know what that is. Y is the square root of 2, and r is 6. So if I work this out, x squared plus 2 squared, the square root of 2 is just 2. And then this would be 36. So I'm going to be subtracting a 2 on both sides, so that cancels. X squared equals 34. if you take the square root of x, that means that x here, let me move it on this side, x is equal to the square root of 34. Sorry, I was thinking if I could break down 34. So the square root of 34 can be broken down as 17 and 2, but nothing more. So in this case, I can't break it down, so I'm just going to keep it as the square root of 34, which is fine. The next thing you want to do is consider the what quadrant you're in. So let's take a look at this quadrant here. So it says that in this case, it needs to satisfy that cosine is less than 0. Now we learned before that if something is less than 0, it's referring that it's a negative value. So it wants to know when cosine is less than 0. So if we go back to that acronym, all students take calculus, this here qualifies for sine, tangent, and cosine. And then the reciprocal is going to be secant, cotangent, and cosecant. So on this quadrant, I'm showing you what one of them are positive. So second, third, and fourth. Okay, so in this case here, it says that cosine is negative. So what we're going to do here is that our graph only shows positive values. So we're going to find where cosine's positive first and then ignore that. So cosine's positive in the first quadrant and the second quadrant. So we want where cosine is negative, so not these two quadrants. Instead, we want these two quadrants, or actually let me use my highlighter. There we go. So it's either these two quadrants, but they can't be both quadrants, right? This angle's in one of these two. So what we have to do is remember that our sine here is positive. So if sine was positive, right, that means that sine is made up of y's. The radius is always positive, but if sine is positive, that means that in this case it had to have been the second quadrant, right? Because in this case sine is positive here. So the quadrant that's the winner here is the second quadrant. So if it's the second quadrant, that's where x is negative and y is positive. So this x value is actually a negative square root of 34. So now I have all of my x values here. And so I'm ready to write my trig function. So I'm going to squeeze this to the other side here. So I'm going to write out my sine, cosine, and tangent. And then I have my cosecant, the reciprocal of sine, secant, and then cotangent. So based off of this here, the ratio for sine is always y over, what's going on here? So you grab a pen. There we go. Sorry, I don't know what happened there. So it's always y over r. So in this case, y is the square root of 2. Oh, well, actually, we were given sine in the first place, so I guess I could just rewrite that. Square root of 2 and 6, my bad. And then cosine is going to be negative square root of 34 over 6. And then we have, oh, sorry, not negative 34. 34 over 6, not 36. And then tangent is y over x. So that's going to be negative square root of 34 over square root of 2. So here's the thing. These two I don't have to simplify here, okay? Because the root here is on the numerator. But this one here, the root's in the denominator. But I just want to remind you that they're both under a root, right? So whenever you have division and they're both under a root, you can actually combine them. So in this case, you could write one big square root. And so 34 put the negative sign outside, there's still a negative sign, so keep that in mind. So negative 34 over 2, the square root, 34 divided by 2 is 17, so it's the square root of 17 and a negative. Notice that when I do this, I get rid of the fraction, and now I just have negative a square root of 17, which is my answer for that one. Okay, and now we're going to do the other side here, the reciprocal. So this side here, cosecant is now going to be the reciprocal of side. So that's going to be 6 over the square root of 2, which means that I need to multiply the bottom by the square root of 2 to make sure that it's rationalized, because we can't have roots in the bottom. So if I multiply the bottom by the square root of 2, that cancels and just leaves you with 2. So 6 square root of 2. If you reduce, 6 and 2 could be reduced down to, well, isn't that just 3 and the bottom 1? So we could really just call this 3 square root of 2. And there's no more denominator, so I don't have to worry about rationalizing anymore. And so the next one here, I have to flip the cosine, so 6 square root of 34. And in this case, I have a root in the bottom, so I'm going to multiply by 34, top and bottom. So in this, when I multiply this straight across, I get negative 34, 6 on the top, and the square root of 34. I can try to cancel some stuff out. 6 and 34 are both even numbers, and so I would get 17 here if I divide that by 2. If I divide 6 by 2, I get 3. So this is really 3 square root of 34 over negative 17. Okay, and so I'm going to box in that. And so for cotangent here, I have, let's see, the reciprocal of this guy here. Oh, did I mess up somewhere? Oh, I did. I think, okay. So I actually did this problem as x. My x was the square root of 34. And so this answer right here actually goes for this one. So let me rewrite that over here. I just noticed that. It's like, hey, wait a minute. That's my x value. So this is 34. I'll just rewrite my work here. My bad, guys. So we got the square root, negative square root of So that would have been my answer for cotangent. So let me erase this answer here. So I actually had to flip that and write that as, because this one was x over y and tangent's y. So I should have had the square root of 2 first. Square root of 2 over 6. So I'm sorry, not over 6, over the square root of 34, negative 34. And so in this case here, if I were to work this out, I have 2 over 34, because remember, you keep the negative sign outside, and then just combine these square roots with division. And so if you reduce this, you would have negative square root of 1 over 17. But here's the thing. So if you were to take the square root, if you were to separate these two, let me make this smaller. Just realized I don't have a lot of space here. Oh, why is it moving like that? Oh, I guess it's not adjusting that well. Okay, I don't want to move too many things. Let's put that back where it was. Okay, so working this out here, we have negative square root of 1 over the square root of 17. And so in this case, I feel like I'm going to run out of room. Okay, I'm just going to work down here. I'm running out of room. So the square root of 1 is just 1, right? So I have negative 1 over the square root. Yeah, I need a shrink. Oh, there we go. Okay, I didn't know if I could shrink it that way. Okay, now I have some room. It's be negative 1 over the square root of 17, but I still have a root in the bottom, so I'm going to multiply the top and bottom by 17. So I have the square root of 17 over 17. And there we have it, our function. I think I dropped a negative. Yeah, I did. There we go. So that was for just tangent. Sorry for that long move there. But yeah, that should be 17 on the bottom. Okay, so that's it for this journal.